Good morning and welcome and greetings. BS, this is BS Racheti. Now we are going to start with lecture number 2 of Unit 1 of Mechanical Systems Engineering. Prior to going to the new topic of the energy sources, whatever we have learned in the last video, just we'll have the refreshness, and then we'll go to the lecture number 2. So in last lecture of the first lecture of Unit 1, energy sources, we saw what do you mean by energy, what are the types of energy, and the detailed definitions of these all types of energy. And then with the figure, we saw what are the non-renewable and renewable sources of energy, and what are the grades of energy. Then we finally just had a quiz. So this was in brief about the energy. Now, the furthest part in lecture number 2, we are going to study. So was about the primary energy, secondary energy, and all these things as per the syllabus, which I discussed in the slide number first video. Okay, so this is in brief about the slide number 1, or sorry, lecture number 1. Now we are going to start with lecture number 2. In lecture number 2, we are going to deal with thermal power plant. Okay, so welcome again, and we'll start with this lecture number 2. So we'll directly start with the thermal power plant. This is the primary energy source is the coal, and from the coal, how the energy is being converted from one form to the other into the final form. This we are going to study in brief about this. So this thermal power plant is based on this main energy source is coal. That is the primary energy is coal, and second it converts this the primary energy is converted into the secondary energy. How that we're going to study in this. So this working as you know, and it is a long term, that is of 31 years I have spent of my life of you can say working in thermal power plant. Means my service is almost 31 years in the thermal power plant at Chandrapur, Parli, and lastly at Nasik thermal power plant, but maximum in 210 megawatt of Russian design. So I know each and every point of this thermal power plant, and keeping in mind of the experience, I just want to give you a brief idea, because you are not going to study in detail as per our syllabus is concerned, and as from the first year point of view. So working of the thermal power plant, how it was, the working fluid is a water and steam. This is called a feed water and steam cycle. The ideal thermodynamic cycle to which the operation of a thermal power station closely resembles is the Rankine cycle. Means this thermal power plant, any device, any engine have some cycle, and based on that cycle, that device runs or operates. So this thermal power plant operates on the principle of a Rankine cycle, which is this Rankine cycle is the base of the Rankine cycle is Otto cycle. Sorry, the base of the Rankine cycle is Carnot cycle, which we have studied in 12th standard. So based on the Carnot cycle, so we'll see how this cycle is being operated on this thermal power plant. In a steam boiler, so you see here there are main 4 components of the thermal power plant: boiler, turbine, condenser, and pump. Here it is shown. So these are the main components through which this Rankine cycle operates. So in the function, what happens? There is a boiler. Inside the boiler, there is a water in the tubes or water in the, you can say, shell. So here in water tube boilers, the water is in the tubes, and heat is outside the tubes. So in the boiler, the steam is being heated. How it is being heated? With the help of a coal, which is coming from the coal mines and coal handling plant and to the boiler. So this coal is not directly coming to the boiler. This is the coal which is coming from the mines is being uh, taken first to the coal handling plant in the power plant, wherein it is prepared. The preparation on the coal is done, and after preparation of the coal, that coal is used in the boiler to take its heat, to burn it, so that the chemical energy inside the coal is converted into heat energy, and that heat is given to the water in the boiler to convert it into steam. The example you can say that what we earlier, nowadays they are not seen, but they may be in the rural areas. The water is being heated by in our houses with like a tank portion. In the tank, it is a shell you can shade. In the shell, the water is being placed, and in the central tube, we have some this cow dungs and this, you can say, woods and etc. will be placed, put, and then by putting some kerosene on this wood and that cow dungs parts, they that the wood and the cow be heated, and that heat produced from this burning of this wood and cow dungs, this water was being heated, and that hot water we used to bath, isn't it? The same is there. This is the boiler, wherein the water is being converted into steam, and that steam is being used in the turbine to rotate the turbine. Again, here what happens, see here. So the steam, which contains the heat, by means of the heat energy, is utilized to rotate the turbine. That is the rotational energy you can call. So speed up to 3000 RPM. So this heat is converted into mechanical energy, and then mechanical energy in turn is the output of the turbine is coupled to the generator. Not shown here, it is shown generator. That generator converts mechanical energy into electrical energy. That electrical energy is to the grid, to the consumers. We are the consumers. We get the energy like this. So what happens here? So coal in the form of, from the nature, from the mines, it comes to the coal plant, and then it is being, after preparation, is taken. So chemical form of from the coal is being converted into heat. Heat is being converted into mechanical, and mechanical is converted into electrical energy. So the main source of energy, primary energy source, is a coal with the in the form of chemical energy, and the secondary source is that is the electricity. So this is the working of the thermal power plant. So what happens? This is the short. So after conversion from heat energy to mechanical energy, the steam which is coming out of the turbine is condensed in the condenser. The purpose of to condense is means to cool. Why to cool? Because this water is special water. That water is being reutilized with the help of pump to the boiler, where it is, this water is again converted into steam. With this cycle, Rankine cycle, at present you don't need to go through it. Just I have shown here, okay, from 1 to 2, it is being heated, it is being pumped. This pumping action is shown here, 1 to 2, pumped. This pumping action is shown on this TS diagram is like this. 2 to 3, it goes into the boiler. So where it gets converted into steam. So 2 to 3 is in liquid state. 3 to 4 is liquid to steam conversion. At this point, it is a dry, and when it is further heated, it is superheated. So 2 to 3 is a conversion from water to steam. 3 to 4 is in the turbine. Expansion of the steam takes place. 4 to 1 is again condensation. Condensed means get cooled, and it is in form of water, and that is again taken to the boiler by means of pump through 1, 2. So this is the process of thermal power plant. Okay. So now that I explained somewhere here. So the exhaust steam from the turbine is allowed to condensate into the water in steam condenser of turbine, which creates suction at very low pressure and allows the expansion of the steam in the turbine to a very low pressure. So not to worry about this, just whatever that told. The condensate along the some flash makeup water is fed into the boiler by a pump called as a boiler feed pump. In the condenser, the steam is condensed by cooling water. Cooling water is shown here. This cooling water is the separate circuit. So this cooling water recycles through the cooling tower. This constitutes a cooling water circuit. Okay. The ambient temperature is allowed to enter the boiler. The ambient air is allowed to enter the boiler after dust filtration. Also, the flue gases come out of the boiler and gets exhausted into the atmosphere through the stack. So the coal is burnt, what happens? The ash is formed or the gas. So gas is being taken out from this boiler to the exhaust. This exhaust gets to the stack, means a chimney. Okay, so these constitute. So what are the main? So in brief, once again, I explain boiler, turbine, condenser, and pump. Okay, so in boiler, water converts into steam. Steam is converted. Steam runs this turbine rotor blades, and means heat energy of the steam is converted into mechanical energy. This mechanical energy, due to rotation in the generator, it converts into electrical energy as shown in this figure. So this is conversion, final conversion to electricity and to be utilized. And exhaust steam coming out of the turbine is condensed in the condenser with the help of cooling tower circuit. Okay, and then the water is being fed to the pump, and it's called as boiler feed pump, and is taken to the boiler for steam generation again. This repeats the cycle. Okay, this is in brief about the thermal power plant. Okay, what are the components we have seen just here? The river or canal. So first thing is requirement is water, second is air for combustion, and third is fuel, that is coal. Okay, so what is the river? As we know, here a huge amount of water is present and is further used for the generation of electricity. Circulatory water pump, that is CW pump, we call it as, it circulates water from the river by the pump. Condenser, the condenser presents here to cool the working fluid, or we can say to remove the heat from the water. So heater, here not shown. Economizer, here that is also not shown here. Okay, no problem. You can say, but what is the function of the heater? As the name indicates, a low or high pressure heater means that increases or decreases the pressure of water. That will explain next slides. The economizer. So when water pressure gets increased, there is a huge amount of heat generates, and that heat is sent from the economizer to the boiler. Above economizer, the air preheater is present, which work is to heat the air, and further that heated air is used in the boiler. So these two things I will explain with the help of a last figure. Okay, so again you are going to see here one more word, superheater. So water heated with high temperature and becomes superheated. Here it becomes steam. Okay, so in this last figure, just see this heater, economizer, and superheater, which I have not explained here. Okay, so here you can see this. When the condensation takes place in the condenser, then it is being taken to the boiler. Before that, this water, which is cold, you can say around 40 to 50 degrees Celsius, is being heated with the help of some part of the steam taken from the turbine to heat it. So they are heated in the heaters. They are either low pressure heaters or high pressure heaters. They are not shown, and that is not required for you also. So then by means of heating, some water gets warm, and that warm water is sent to through economizer. So economizer, what happens, and superheater, what happens? So when the water is passing through the economizer in the boiler, the coal is being burned and the flue gases before going to the stack, they are passed over economizer and separator. So what happens due to these gases, when having high temperature, they exchange the heat with the water which is going to the boiler. Means high temperatures water means steam formation will take place easily and fast one. That's why they are being heated in the economizer. Then the stack goes to the then the exhaust gas goes to the stack. Same thing when the steam is generated, it may be dry or wet. So when it is passing to the turbine, before passing to the turbine, again this exhaust gases passes over the separated tubes so that heat exchange takes place and the separated, they become separated, means absolutely dry, and then that is utilized in the turbine. That is the function of economizer and separator. Air heater is also shown here. So air is required for the combustion of the coal in the boiler. So if the air is cold, it will take more time to combust. So if the air is hot, then it will be lesser time to combust the coal. So this air is also being heated by means of this exhaust gas which is going to the chimney and is passed through the air heater. So the heat exchange takes place and that hot air then taken to the boiler. So that is the function of the air free heater. Okay, this is not needed actually, but components you can explain. Okay, so boiler. Now what is the boiler? Here coal is burning, which means that heat is producing. That heat is used to heat the water and water changes into its property and it tends to separator. Here it is becomes steam with high heat. In the boiler, there is a two section. One is a coal storage section and coal handling, which works to store the coal and further use when needed. Ash handling and ash storage plant, which works when the coal is burned, the ash produced, that ash goes to the ash storage. So there are two compartments. Means one is the coal storage and the other is ash storage. Okay. The function of the separator just we saw. Then turbine, the main function of the turbine is that when the steam strikes the turbine, the blade rotates and it converts the heat energy to mechanical energy. And the generator, here the use of a generator, the mechanical energy is converted into electrical energy, that is the electricity. Okay. So what are the advantages and disadvantages of steam power plant? I hope you understood the working principle of thermal power plant and the components of the thermal power plant and what are the merits and demerits of steam power plant. Just we'll see. Generation of the power is continuous. Once you start this thermal power plant, there is no breakage. It's continuous power generation unless and until the coal shortage is there. Otherwise, it will be a continuous generation of operation, generation of electricity. Initial cost is low compared to hydro power plant because in the hydro power plant, construction of dam is very, very costly, whereas the construction cost is very less compared to hydro power plant. Less space is required. For the hydro power plant, it is required more area for catchment area for water storing, whereas there is such no space is required, very less space is required comparatively to the hydro power plant. This can be located near the load centers so that transmission losses are reduced. Means this can be erection, installation of this power plants can be near to the cities so that the whatever the power is generated from the thermal power plant, it can be sent to the you can say a load centers which are nearer so that the transmission losses are reduced in thermal power. It can respond to rapidly changing loads. Means if the load variation is there, if the demand increases suddenly, so the thermal power plants are such that they can boost up from 100 megawatt to 200 megawatt within a short period of time. Or if it is a requirement is less than from 200 to 100 megawatt, then this can be also reduced. So it means the thermal power plants are they respond very fast to the changing loads. These are the advantages. So what are the disadvantages? Long time required for installation. So initially, when we see, when we, I was not in the project, but we are seeing that our system concern projects area, and we were seeing that 4 to 5 years were required. Sometimes in one of the unit it was required 8 years for completion or erection of the thermal power plant. So that is the most disadvantage and time consuming and cost consuming also. Transportation and handling of fuels is major difficulty. This is more important because transportation of coal, transportation of oil is also required. Transportation of again gases, this ash, etc., is a major difficulty because in nearby city pollution problem is there. Transportation from rail by road, again this pollution constraints are there. So this transportation and handling of fuels is more difficulty. Efficiency of the plant is very less. So this efficiency of plant is very less. If anybody asks why the efficiency of thermal power plant is less, so you can say by seeing this figure. So when the exhaust steam coming from the turbine is condensed. So in the condenser, what we are doing, the heat is there still in the steam, but we have to condense it into water, convert into water, and that we have to reuse the boiler. So in the condenser, 45% of the heat is being removed by the condenser. Means you can say 100 minus 45. So 45 maybe 55% efficient. And again, there are some other losses which contributes to 10 to 15%, means the efficiency of the turbine is around 40% only. So that is the main disadvantage. This efficiency of the plant is very less. Power generation cost, that's why, becomes high compared to hydel power plant. Because as the efficiency is less, you have to expand, you have to expenditure, you have to incur expenditure more and more of coal. The cost almost goes high. So hydel power plant, there is no such extra expenses incurred. Only water is there, so no need of purchasing of coal, transportation of coal, etc. is required as in the hydropower plant. So automatically the generation cost of the hydropower plant is very less compared to thermal power plant. Though when I was there, so it was around 80 paisa to 80 paisa around of cost was coming for hydel power plant. Comparatively to thermal power plant, it is on an average 3 rupees per unit. So automatically the cost of the generation is high. So maintenance cost is high. As there is so many auxiliaries, so many devices are there to have this electricity conversion of this fuel energy into electricity. So automatically the maintenance cost also increases compared to other power station or other power plants. Hydro power plant, very less auxiliaries are there, whereas in thermal power plant, there are so many auxiliaries. That's why the maintenance cost goes on higher side. So this is about thermal power plant. Now, what are the basic formulae used for the efficiency? You might have also studied plant efficiency. I will directly go with the formula: work output upon heat input in joules. The plant efficiency is also defined as output power upon input power. Output power is brake power, you can say 2 pi nt upon 60, where n is the speed of the turbine in RPM. RPM means revolutions per minute. T is the torque in Newton meters. T is also can be written as a force into radial distance. That is T is equal to F into R. Output power is just we saw 2 pi nt upon 60 into 10 raised to 3 means kilowatts. Calorific value of fuel. This you just note down. Calorific value is equal to heat released from the fuel divided by mass of fuel burned. So heat released in terms of kilojoules and mass of fuel burned in terms of kg. So calorific value means the heat contained by the coal is called as the calorific value, and this can be found out with the help of heat released divided by mass of fuel burned. So now we have seen output. What is about the input? Work output we saw. Heat input is calorific value into mass of fuel burned. Means mass of fuel, how much mass of fuel is burned with the heat content by this mass of the fuel. that is CV into mass of fuel burned. You can say, therefore, heat input is equal to calorific. In terms of, this is kg. In terms of volume, it is being written as a calorific value into volume of fuel burned in terms of meter cube. So volume will be in meter cube per second. Calorific value in that case, it will be kilojoules per meter cube, not kg. So automatically heat input will be in the form of a kg per second. So from that, you can find out, you know the now power output, output power, and you know the heat input. From that, you can find out the value of plant efficiency. So one example we just see in brief again. So a steam power plant has coal consumption of 165 tons per hour. Calorific value of coal is 3,500 kilocalorie per kg. If the power generation is 250 megawatt, find overall efficiency of the plant. Use relation 1 kilocalorie is equal to 4.18 kilojoules. This is the conversion factor. So don't worry, just you initially will be getting a little bit, you can say, under tension while solving. But my opinion, while solving any problem, you just keep your mind cool and calm, and whatever the things given, first write that one. And from that, and also after that, you write down the formula. Then you can get the answers easily. So what are the given here? Mass of fuel is given 165 tons per. Coal consumption is 165 tons per hour is equal to 165 into 1000 upon 3600. The hour is converted into seconds, ton is converted into kg. So 1 ton is equal to 1000 kg, 1 hour is equal to 3600 seconds. So calorific value, which is given as 3500 kilocalorie per kg into 4.18 is a conversion factor. So it will come be is it. So we have to take this kilocalories in MKS units and kilojoules is in SI units. So 3500 into 4.18, that will be the calorific value. Output power is also given in terms of 250 megawatt. So 250 into 10 raised to 6 watts, or 10 into 250 into 10 raised to 3 kilowatt. Then find efficiency. Now you have got output is there, input is given, then you can find out the values of efficiency. So heat input is a calorific value into mass of fuel burned. Calorific value is 3500 into 4.18 into mass of fuel burned is 165 into 1000 upon 3600. So heat input is equal to 6,70,000. Sorry, 6,70,500 and 41.666 kilowatts. So this is the heat input. Then efficiency is equal to output is given in the form of 250 into 10 raised to 3 divided by 6,70,541.6667. So the efficiency comes out to be 37.28%. So as I told, it is around 40% due to heavy loss of heat in condenser. Second example, a steam power plant has coal consumption of 165 kg per hour with calorific value of coal as 18,000 kilojoules per kg. If the speed of the steam turbine is 1100 rpm, radial distance is 1.5 meter, and generated force is 3.2 kilonewtons, find generated torque, input power, output power, and efficiency. These are very simple formulae. Simple examples or questions asked on this output efficiency. Just you have to be patient. See what is given. We know that torque is given by force into radius. Force is given in terms of 3.2 kilonewtons into kilo means 10 raised to 3 into 1.5 is the distance or radius. You can say 4.8 into 10. Hello. Hello. हाँ बोला. हाँ बोला. हाँ बोला. काय नको नको आम्हाला काय गरज नाही. So where were we? The torque is equal to force into radius. Torque is 3.2 into 10 raised to 3 newtons into 1.5 meters. That is 4.8 into 10 raised to 3 Newton meters. So heat input is equal to calorific value into mass. So calorific value is how much? 118,000 kilojoules per kg into mass is given 165 kg per hour. You convert it to seconds. It will be, the answer will be, heat input will be 825 kilowatts. So output power is equal to 2 pi nt upon 60. 2 pi into n is 1100 rpm. Just before that, you have not written here. You just have to write the given data first and then go for the solution of the problem. Then into 4.8. So what is the 4.8? T. We have calculated into 10 raised to 3 divided by 60. That is the formula. 2 pi nt upon 60. It is a 552.92 into 10 raised to 3 watts. Means it is a 552.92 kilowatt. So the efficiency is given by output power upon input 552.92 divided by 825 is equal to 0.670. That is a 67.028 efficiency. This is a theoretical efficiency we calculated. Okay, with these two examples, I hope you understood how to find out what is the input, what is the output, and what is the efficiency, and how to calculate the efficiency. Okay, so now quiz or MCQ. So these are the MCQ for you people. You just go through it, and if you have any difficulty, doubts, you can ask me. I have given the mail ID. Okay, so on the mail ID, you can give a reply. Thank you very much. Descriptive questions are also there. Just go through this. So I stop here because we have gone little more today. I hope you understood. Thank you very much.